What's going on, ladies and gents? Today we're going to be talking about, well, several things actually. So the first thing is going to be regions and availability zones. This is a basic topic that you need to understand. Also, we're going to be getting into, now we're actually going to start getting into creating instances, the types of instances we could create, setting up a web server, security groups, and auto scaling. Now, with that said, this video might be a little long, so yeah. All right, first up, regions and availability zones. So the reason why you need to understand this is because I know you've seen this when you created servers. So I got a chart right here. So these little circles are called availability zones. They're actually data centers in these circles. They're Amazon data centers. I'm not too sure if this is the actual location of them. This is just a demonstration. So let's say that this area right here, there's a Amazon data center. This is another Amazon data center and another one right here. And all of these are in the region of London, which is called EU West 2. Now the availability zones available in London are EU West 2A, 2B, 2C. These are all connected, by the way. So just in case this blackout, or if you only have one, if you're not scaling this, meaning that you only have your server running in 1 and 2A. If you do have your server running in 2A and there's a blackout in this area, well, your server just went down. So it's actually a good idea to actually have them at least in 2 of them that's in the same region, because it's faster like that. Like I said, these are connected with one another. So just in case someone does have 2 servers running, one server running in two instances or 2 availability zones, if this goes down, well, it'll start up in 2B, or 2B is still up, so his website is still up or something like that, or the service is still up, right? So this is a very brief summary of what regions and availability zones are. And the region is, like I said, London, and this is the availability zones. And that's what you need to understand about these, because you are going to be messing around a lot with these, choosing where your server is going to be located at. So now let's get into actually creating a EC2 server over here in our dashboard. So when you're creating a new EC2 server, you're ordering a virtual server with the specifications you select that's delivered directly to your AWS account with 1-minute shipping. So let's actually go there. Services are, obviously, you could either type in EC2 right there, or you could actually click it right here. And we're going to be clicking on the launch instance button right here, launch instance. All right. So virtual machine images in AWS are called AMIs, or Amazon Machine Images. So on this screen, you can select from any number of AMI images that Amazon has already created. So you can start with a blank server that includes Linux or Windows Server, and it's already set up for you. So we're going to actually select this one right here. As you can see, it's free tier eligible. Actually, most of these are. Look at that. But I like Ubuntu, so we're going to do Ubuntu, which is, I'm actually get the latest one, which is right here, 18. So let's get the 18 one. We're going to select that one. And we're going to select the 12 or T2.micro. I don't know why I say point. .micro. Don't worry what these are. Obviously, you already know. You can actually see what's going on here. The more memory, more CPUs, obviously the more expensive it will get. So we're going to just get for the free tier, or a free tier eligible. Let's do that one. And we're going to just go to the review and launch. All right, in the bottom corner right here, just click on launch. So to actually connect to the instance either through SSH on the terminal for Linux instances such as this one, or Remote Desktop Protocol or RDP for your Windows Server instances, you'll need to create a key pair, which will become the password for accessing this instance. So in the first pull down, we're going to choose create new key pair. We're going to name it AWS Demo. You can name it whatever you want, but I'm going to say AWS Demo, and we're going to click on download key pair. And let me actually go to document or downloads and just save. And then we're going to click on launch instance. And then down here, view instances, and you should see your instance right here. And we're going to give this name or this instance a name. So I'm going to just call it web server 1. That is it. All right, now that we see that our instance state is running, we're going to just select it and connect. Click connect. And this will tell you how exactly you're going to connect to your server. If you're using Windows, you could use PuTTY, but you could also use the Git bash. So that's what I'm going to be doing. Let me just open that up. My desktop, Git bash here. Okay, here's my Git bash. So now what we need to do is actually go and get our, well, what did we call it? AWS Demo.Pin file, the one we just downloaded. Okay. Now the public key is already installed on your instance for you, so you don't have to worry about that. So, oh, by the way, keep in mind that this AWS Demo Pin file is the only copy there is. You can't get it from AWS later if you lose the file. So if you have a team, you'll need to share this file with them securely so they can connect to your instance. I'll usually take the contents of this file, of the pin file, and I paste it into my team's encrypted password store, such as LastPass or 1Password, and only share it with the people who need it. If you lose your key pair, there's no way to recover it, but you can go through a pretty complicated procedure that's listed in the AWS docs to create a new create a new key pair and install that new public key on an image of your infected instance, and then relaunch it. But to avoid all that, just don't lose the key pair. Honestly, it really is a pain. So I usually put the pin file in .ssh. Now, if you have GitHub and you already do SSH into your GitHub, you already know that you already have a file called .ssh. So I'm just going to move that pin file inside that folder. So I'm going to, it was in my download. So let's go to downloads. So we're gonna move mv /downloads. What was it called? AWS. Where is it at? Demo. There it is, right there. As you can see, it's right there. We're gonna move this to my /.ssh folder, and there you go. Now, if I go to actually ls .ssh .ssh, I have my AWS Demo Pin right here. Awesome. So now what we need to do is, it says right there, just give it permission. So that's what I'm gonna do. So cmod 400 and then .ssh and AWS. Giving that permission. Now the next thing we need to do is actually connect to your instance using the public DNS. So just copy this, copy it. Oh, you could just copy the bottom. I didn't even see that. Copy this one, and then let's go inside of it, and then press enter. And you should, yeah, okay. Are you sure you want to continue connecting? Yes. Since this is the first time, it's going to try to get a fingerprint, which is basically a virtual handshake. So just say, yes, I do want to connect, and I got permission denied. And the reason why is because over here, I need to give it the actual where it's actually located. So .ssh/ there you go. Now, what is still denied? All right, I connected. I had to actually give it the actual absolute path. I don't know why it did not take the tilde, but I actually had to say MIC and the users and the G and then .ssh and all that. I just had to write this whole thing down. Usually it will take the tilde. I don't know why it didn't take the tilde, but yeah, if it doesn't take the tilde for you, just write out your whole entire, like, where exactly are you at, what hard drive, inside the hard drive, what folder, and then inside, just from in there, yeah. So once you've done that, when you press enter, now you're inside your actual Ubuntu server that you just launched. As you can see right here, my Ubuntu server, Ubuntu. Now we're gonna, so I do want to talk about the instances, not that much though, so I'm just going to give a brief summary. Here we go. If you actually go to AWS.amazon.com, EC2 instance types, these are all the instance types that you could actually get in the AWS. Now there's general purpose, like if you're not doing so much, and there's computer optimized, memory optimized, accelerated computing. Like it just keeps on getting better and better. But obviously, look at this, man, 10 gigabit, like 100 gigabit, like yeah. So yeah. Anyways, these obviously they're gonna get much more expensive the more down you go down in these categories. So general purpose, the most common ones are the T3 and the T2. But yeah, we use the T2. I'm pretty sure we just used the T2.micro. Yeah, I thought so. So the T2 micro, that's the one we used. So it's not that big of a deal. But like I said, if you're running like a bigger project, like you're trying to, I don't know, for data, you want to build a machine learning. You need more things than what than the general purpose actually uses. You probably need, I don't know, memory optimized or accelerated, depending, right? So I'm just telling you there's different types of instances that AWS offers, and here they are. And you could actually, I'll have this link in the description so you can see it. But yeah, just don't get any of these. You are gonna get billed for it, but just do some reading on these, and you know, if there's one that actually fits your needs, then use it. If there's not, then please, by all means, do not use it. Also, there is this other website, ES2instances.info, where it does give you a rundown on how much it will cost you, which is actually really accurate. Well, it's pretty accurate, you know. It'll tell you is it for a month, a year, and all that stuff, or you know, cost, is it hourly, daily, monthly, annually, and it'll update to that right there. Look at that, $2,382 annually. Screw that. All right, so let me actually see what's on a. What is this? $273,000? Are you kidding me? What the hell is that? It's just $41. There you go. Where's our T2? There's our T2 micro, which will cost us $101 annually. Hey, it's not that. That's pretty good actually. That's actually pretty good. I'm not gonna lie. All right, so enough about that. Let's actually go back in the terminal and start using our new server. The first thing you always want to do when you actually get inside your server is actually update it. So what do we have to do here? Sudo space apt -get space update, and hit enter, and this will update the server to its, well, to the updated Ubuntu standards, you know. So we're gonna wait for this. Oh, and it's done. Now we're gonna install Apache, or you can install Nginx or whatever other web server you want to install. But Apache, I'm gonna be installing that. So let's actually one up arrow install Why is it capitalized? Install Apache 2. So you're gonna do sudo apt-get sudo space apt-get space install space Apache 2. Hit enter. Yes, you do. And it's gonna take a while, so I'm gonna just, stop right now. All right, now it's done. Now what we could do is actually minimize this. Okay, first of all, Apache installed, so we should at least see the Apache guide start or guide start, right? Guiding start when you launch this application. Now exit out this. All right, click on your web server 1, and down here in in description, you could actually see that where is it at? It should be around here. There it is. Availability zone. We already talked about what this is, and when we created our instance, Amazon just gave us US East 1B, which means that we're already in a server, so we could actually see this online. And here's our public DNS right here. So I'm gonna just copy this over here. I'm gonna paste it. And guess what? We're not going to see anything. And the reason why is because when we created the instance over here, we just blew right through the configurations, and it gave us a default security group. So let's actually talk about security groups now. So let's actually bring this up a bit so that we see more about it. All right, let me actually find where it's at. Let me see. Right here, security groups. You can see that we're actually using something called Launch Wizard 1. You might have a similar thing, or if not, it don't matter. This is if you follow the exact same steps, this is default. Whatever you have here, it should be default to whatever Amazon gave you. So if you actually look at the inbound rules, this will give you a hint of what the security group does. So the security group allows 0.0.0.0/0. The / here is called a net mask, and it's a shorthand abbreviation for an IP address range. So for instance, /32 means the range is a single IP address, whereas /0 means all IP addresses. So this rule says that the server will accept incoming traffic over port 22, which is the SSH port, from any IP address on the internet. Okay, so now we know why our web server doesn't work, because this security group needs to also allow port 80 traffic, which is the HTTP traffic from anywhere on the internet. So click on the view inbound rules over here. And I said inbound, it's outbound. So click on that and you'll see that the server can make an outbound connection with any destination on the internet using any protocol. So this means that our server can go out on the internet and get software updates or use external APIs. So let's actually get inside the launch wizard and see what's going on. So we're getting more specifications of what the security group actually does. And let's go to the inbound rules. Let me actually bring this up right there. And then let's click on the edit button so we can make some changes around here. Okay, so first of all, it's not a great idea to have our SSH port publicly exposed to the entire internet. Although AWS generated a pretty strong private access key for us, it's better security if we limit the IP address that can talk to our server via SSH. So under the SSH rule, in the source column right here, we're going to do my IP address. So I'm gonna just block this out. I don't want you guys knowing what my IP address is. So anyways, what was that? Oh yeah, my IP address. So AWS will automatically fill in your current IP address, and that /32 you see right there means that the IP range is now restricted to only your IP. If your IP changes because your ISP at home randomly switches your IPs, I don't know why I said S, but your IPs, or you take your laptop to the coffee shop, you'll need to come back into this screen and select my IP again so it can update your IP on the security group. So now we're going to click on the add rule. And right here, we're going to select HTTP. Where is it at? Right there. We're not doing HTTPS because that S stands for security, and we don't even have it secured yet. We haven't secured our server yet, so we're not going to be able to get this one anyways. HTTP for now. In my mind, I'm like, did I say security for HTTPS? It's not security. It needs to be secure. That's why the S is there, to be secure for SSL. I hope you understand that. I don't know what I said. I just forgot. My mind just blinked right now. Ooh, brain fart. Anyways, you can see that once you select the HTTP, it will automatically fill out this rule as TCP and 80 port. And for source, select anywhere. So this is going to be access. You can access this from anywhere now. So this is actually save the rules. It's doing that. It saved it. Awesome. Now let's go back to our page and actually refresh. It refreshed for me. And guess what we have? Our Apache 2 default. It's the default page. Damn it, dude. Anyways, there it is right there. our server is up and running, and we have our default page for Apache. Apache, I don't know how you pronounce it. I mean, there's a lot of variations of it. All right, now that we have this up, it's time to talk about auto scaling. Now I've already done some videos about this, and it's in Node.js, and I have a link of the series down below if you want to watch that. I talk about it more in depth, but since we're doing it on AWS, I thought it was worth mentioning it right now as well. So remember, EC2 stands for Elastic Compute Cloud, and the word of the day is elastic. An auto scaling policy can tell AWS that when an event occurs, such as our instance CPU usage goes above 80% for 5 minutes, to stretch our one server into two. And then we can tell it to shrink back down again to one server when things have calmed down again. So your application needs to be designed in a way that if 1 or 2 or 10 clones of your single server come online, that your application can load balance your traffic across all these new servers. Now this is called horizontal scaling. You could think of it as a busy grocery store. The manager will open several new checkout lanes to reduce wait time. When the rush is over, they'll close those extra checkout lanes. This is different than vertical scaling, which would handle the problem by still only having a single checkout lane, but just putting a faster cashier and speeding up the conveyor belt. Vertical scaling in AWS is fairly easy. You just stop your running EC2 instance, which will cause a little downtime, and change the instance to a larger, faster server with more CPU cores and RAM. But this has its limits, and all large applications use horizontal scaling to handle an increase in traffic. We're not going to get into how to set up an auto scaling for this video, or for the series anyways, but we will create an AMI snapshot of our current running server and create a clone of it manually, which is one of the first steps of setting up auto scaling anyway. So in our EC2 console, we're going to click on instances right here. This is going to bring us back to this page, and click on actions up above right here. Oh boy. And in instance states, you can see that you could start or stop the instance, and you'll also see a reboot option. Now, if you stop an instance, you won't be charged for the compute time while the instance is stopped, but you will be charged for the storage cost of its hard drive, which are pretty minimal. Don't worry about it. And plus, it's free right now. You can click to start and bring the instance back up again. If you click reboot, it will force a software reboot of the virtual machine. So this is very important, so check this out. These are different actions in AWS. If you stop and start an instance, this virtual machine will actually move to another physical server in the availability zone. So do this if you're having problems connecting to the instance, because it could be a hardware failure on the AWS side. So back in the details pane right here, go to status check. If there's anything wrong with the system, you will see it right here, and it will say something along the lines hardware failure or something like that. I don't know, but right now obviously our instance passed, but if you do get something wrong with it, it's more than likely going to be a hardware failure on the AWS side. But it actually takes a few minutes for AWS to see the problem. So you might notice the problem before the alarm goes off. If you reboot an instance, it'll come up faster, but it stays on the same physical server. Now, that's very important. So let me repeat that one more time. If you reboot an instance, it'll come up faster, but it stays on the same physical server it was on before. So if you click on actions again, let's do actions and click on actions. Go to image, create image, and this is where we're going to create our instance of our server. In the image name, let's just say AWS Demo. And then you're going to see an option right here that says no reboot. AWS needs to reboot the virtual machine to take a proper image of it. So this properly shuts down the file system and lets AWS take a clean image of the virtual machine. But it does cause a little bit of downtime. If you select no reboot, well, good luck to you. All right. So click the create image button and then close. So over here on the left side under images, click on AMIs. And then you'll see a spinner next to our AMI while AWS reboots the instance and takes a snapshot of it. Actually be ready. So I'm actually going to come back when it's actually ready. So now that it's available, the status is available, click on it, make sure you checked it and all that, and click on the launch button. Now we're back in the EC2 launch screen, but we're launching a new server based on our server image. Again, select the T2 micro. And this time we're not going to just review and launch. We're going to actually put up configure instance details. So under the subnet, select an availability zone that's different from the other instance. So if I'm not mistaken, ours was 1B, US East 1B. I'm just going to say US East 1D or 1A. Let's do 1A. 1A. And it doesn't really matter. Like I said, when it comes down to it in availability zone, they're all connected. So I just wanted to go from A to B. That's it. So when you're done, just click next and then click next again. And let's configure our security group. And we're going to be selecting an existing one. Right now it's trying to do a default one like it did for our very first server, which we don't want. We already did something where it actually connects. You could connect to HTTP. So we're going to actually check launch wizard 1 right there. And then all we want to do, it gives you all the info down here as well. So we're going to just review and launch. And let's do launch. All right, this time is going to be a little different. If you, like I said, if you're a secure freak or a nut job, those security people, you could actually do another key pair, create a new one, and then do all that stuff again. I'm not. We don't. Typically, you do not do it. If you're creating a new instance of the same server, you're going to use an existing key pair of that server, which was AWS Demo. I acknowledge, whatever. Launch instances, which is right. View instance, and we're going to see it spinning up right there. All right. So we made sure that this instance is in availability zone 1A, whereas my original one is in zone 1B. I'm also going to rename the name to web server 2. And I messed that up. Web server 2. Now we can actually see if it's actually working. Make sure this is clicked. Go to description. And security is still initializing. Don't worry about it. It's going to run okay. Don't worry about it. And we can actually copy this. And we could actually paste it in our browser and see what's going on. And what do you know? It's running smoothly. The reason why, like I said, this is a copy of our original, which we did configure to actually work. So, and as you saw, it does have Apache installed in it. So an AMI image is a great way to take a snapshot in time of your server in its full configuration and then launch new instances to, say, handle a spike in traffic or restore the instance to a previous state if it gets messed up somehow. So we're actually going to leave these instances running and we'll connect them together later on the videos. But remember, once we're all done with this video or the series, we're gonna actually terminate these so that way we won't get billed. All right. I mean, we're not gonna get billed for a year, so if it takes me a year, it's fine. Well, it's not fine if it takes me a year, but you get me. So that was it for this video, guys. We went over a lot. I know we did. I'm super sorry that it was a long video. So we just went over how to create an EC2 instance. We went over the types of EC2s, not really deep into it, but I did give you a page down in the description. We set up a web server, Apache, and then we configured the security groups, to actually work on all HTTP and actually secured our SSH port. And we also went over auto scaling, not as much, but just a bit, because I already did a series on auto scaling, which I'll link down below as well. So thank you guys for watching this video. I really do appreciate you taking the time out of your day to watch these videos. It helps me out and my channel out. So if you like the video, please hit the like button, subscribe if you haven't, and leave a comment down below on what you thought about the video so far, or the series so far. I think this is the longest video I've done for a while. So thank you guys, and I'll see you in the next video.